Hey guys, uh, you're watching this. It's either Monday or Tuesday, August 24th or 25th, and you are going to be taking notes on graphing and CER method today. First thing, if this is Monday for you, you have not met with me, and so you need to save a page, the very first page of Unit 1. You're going to write our essential question, which is why is water essential to life? We'll come back to this tomorrow. So for now, just go ahead and write it there so you can save it. And then you're going to turn to the next page, and this is where you're going to start taking notes. I'm going to encourage you to pause this video and make sure you can catch up with writing all your notes down, okay? Because I'm going to move through just like as if I've already written all these out, and so I'm going to move pretty quickly through them. So the video stays fairly short, but you can come back and pause and make notes as you need. So the title of this is going to be Communicating Information from Our Labs. And so basically what we're looking at is how can I communicate effectively what I have learned or what I know from doing the lab. Okay, so we're going to look at two things. We're going to look at one, the CER method and what that is very quickly, and we're going to look at graphing. So first things first, let's look at what we're doing in class that's going to lead us to this point. So you come into class, we're going to be trying to solve a problem. Okay, we're going to write this in a form of a question. Which fertilizer is most effective on plant growth or something like that, right? We're going to have a problem for you. We're going to carry out a controlled experiment, hopefully, in class. And a controlled experiment is I'm going to change just one variable. That variable is called the independent variable. It's what I'm studying. And I'm going to have a control group, which I'm going to use for comparison. So let's say we're going to that fertilizer example. My control group is not going to have fertilizer in it. The control group does not get the independent variable. Okay. And then I'm going to get some results. And the big thing on what we're about to talk about is just how do I communicate those results effectively once we have them. So the way we're going to ask you to communicate results is through the CER method. And CER stands for claim, evidence, and reasoning. And it's going to be three parts. You're going to do this on a lot of labs, maybe not every lab, but you will get better at it. It's a little hard at the beginning, so have no fear, though. You will get better. It just takes a little practice. So the very first thing is the claim, okay? And the claim is just a statement that answers the question. Is it similar to a hypothesis? Sure. Hypothesis, though, is usually done before the lab begins. It's what you think is going to happen. The claim is what you know happened, and you know what the answer is to that question. Okay, and it's going to be a statement. It's not going to be an if-then statement. It's going to be one or two sentences long. You're not going to have any I's or me's, no pronouns. Okay, and it's, again, not an if-then statement. It is fertilizer B was used and showed the most plant growth or something like that. Okay, so here's some examples I put down here. Fertilizer B resulted in more plant growth. Oxygen was produced at a faster rate under blue light conditions. Those are statements. They sound like they are facts, right? So that's going to be your claim. That's usually the easiest thing to do. What were the results and what was the answer? Okay. Then we're going to move on to the evidence section. Okay, the evidence section is usually pretty good too, but here's where we get some specifics on how we want to graph. So in the evidence section, you're going to collect one or two types of data, quantitative or qualitative. In quantitative, you are going to be looking at numerical measurements, okay, something with numbers in it, 10 centimeters, whatever. Qualitative is going to be more descriptive. The plant turned brown. It was withered, things like that. Okay, what things look like, smell like, things you can observe. Okay. And what you're going to do with that information is you're going to drop it into a data table. Okay, and so I'm going to point out, and I kind of messed up mine a little bit here, but I didn't want to redo the whole thing. So let me get this up here a little better so you can see it. And in the data table, the far left column is typically your independent variable. It's what you're measuring or what you're changing, what you're trying to test. And so in this case, we're testing fertilizers. So that's going to be my left-hand column. Okay. This section is going to be your dependent variable. So in our case, we're going to be measuring growth. Okay, and we're going to be measuring specifically growth over time. And so in here you have week 1, week 2, week 3, week 4, and then you have the measurements down here. If you notice, I put centimeters, so I have my units on there. And then, of course, you're also going to have a title. I kind of ran out of room, but it should include your independent and dependent variables. So if I was going to title this, I might put growth of plants using different fertilizers or something like that, right? Something that's going to have my independent and my dependent variable both available. Okay, so if I read it, I kind of know what the table's about beforehand. Then what we do is we take this table and we can use that to create our graph. Okay, so in our graph, let me turn over here. These parts have to be included every single time you do a graph. If you don't include it, I promise you will lose points. And so it's silly to lose points over something as simple as a title, right? So one, if you're going to do your graph, the very first thing you do is add your title. Again, your title should include your independent and dependent variables, okay? Then you're going to come down here and you're going to label your axes. Your y-axis is going to be your dependent variable. It is what you are measuring, okay? So if I'm measuring plant growth, then I might write here plant growth, and then I need to make sure and label my units in centimeters or something like that, okay? The x-axis is going to be your independent variable. Oftentimes, your independent variable, what you're going to end up putting is time, okay? It's something that the experimenter has changed. So time often ends up on the x-axis. When in doubt, time goes there. But it could be, like, for example, if we were doing fertilizers, if you were measuring rainfall over time, again, time would be on the bottom. And so you'll have to label it and, again, add your units, okay? Then, of course, if you need a key, so if you've got multiple lines or bars, then you're going to want a key. And then scale is obviously really important. One thing that you can lose a lot of points on is if your graph doesn't take up the entire space. And so let's say I give you 10 lines. I want you to use those 10 lines. Don't only go up to here and then have this tiny baby graph inside this like large area. And so a good rule of thumb is, what is the total that you need? So let's say the very top number is 200, okay? And I gave you 10 lines. Well, if you took 200 and divided by 10, that gives you a good scale for each of your lines. And so that's a kind of an easy mathematical way to figure out what your scale is take your total that you need and divide it up over the number of lines that you have. Again, use the whole graph. That's really important. Now, if you're doing a line graph, that's for things that have change over time. If you're doing a bar graph, that's usually when we're comparing groups. And then, of course, a pie chart, which we very rarely use, I feel like, is when you're showing percents of a whole. Okay, and so making sure you have the correct graph is also really important in relaying information. Okay, line graphs are easier to change over time. It's easier to see using a line graph. It looks really wonky when it's in bars. And so using the correct one is important. So once you have this done, you've got your evidence section. What we typically do is we take this and we write it out in paragraph form. So we take whatever our evidence is here and then we write it out. Plant B had 7 centimeters of growth over 4 weeks. Plant A had whatever amount of growth over so many weeks. So you're basically taking the graph and putting it into words. That's going to be your evidence section, okay? Then comes down to your reasoning section. And this is what's going to be the most work. It's going to be the most practice. But this is the analysis or the why. So not only did you write your claim, you collected your evidence, but how does your evidence actually support your claim? What are the scientific principles behind the why? So if I said plant fertilizer B had more growth, why? Why did it have more growth? Were there extra nutrients in it that, were needed for photosynthesis? What was the scientific principle behind it? Okay. And that shows us if you really understood what the lab was about and you're understanding the content. Really important. You do not just repeat your evidence. You don't say the reason fertilizer B worked better was because it had 7 centimeters of more growth. The why did it have 7 centimeters of more growth? And so the reasoning section is going to be really important. So again, this is just a quick overview of the CER method. We have our claim, which is our statement that answers a question. We have our evidence, which we have put into a chart, a table, and then created a graph. And then, of course, we have our reasoning section, which is the analysis or the why. Okay, we will do more with this as time goes on. Appreciate you listening. And apparently the Stars just scored a goal. So go Stars.